Assalamualaikum and good day to all the panel. My name is Nurnabihah Najaa Binti Mustapa Kamil and my matrix number is B051820024. I'm a 4-year student from BMFG. For this semester, I'm taking the final year project 1. My supervisor is Prof. Madhya Dr. Liu Pei-Jun, and today I will present about my title for this project, which is the effect of different concentration of titanium dioxide, the TiO2 powder, on the surface modification of my steel. For the introduction, based on the journal that write by Kumar et al. 2012, it said that the surface modification process is an incredible process that used to improve the mechanical properties of the material through the coating process. Electric discharge coating, or also known as EDC, is the continuity from the electric discharge machining or EDM process, where EDC use the reverse polarity. Electrode will be connected at the positive terminal, while the piece will be placed at the negative terminal in order to promote the material deposition. This is the schematic diagram for EDC process from the previous research. There are two common techniques for EDC process, which is powder suspended or PMEDM, and the other one is powder metallurgical electrode, also known as PM electrode. Okay, now I will explain about the problem statement for this study. Steel is widely used in human life, such as building construction, bridge, and pipeline in the petroleum industry, chemical industry, electrochemical industry, and food industry. However, steel is a low hardness material. It only contains about 0.25% of the carbon and below. Therefore, rusting is the most common type of defect that will occur to the steel structure along with their lifetime. Based on the topic for the study and the problem statement, there are two objectives that is come up, which are, the first one is to investigate the effect of titanium dioxide, TiO2, concentration on the characteristic of EDC sample in terms of surface roughness, micro hardness, coating layer thickness, and deposited element. The second one is to define the optimum concentration of TiO2 powder for improving the mechanical properties of the steel. This is the scope of the study. In this study, the technique of PMEDM or powder suspended will be used. The machining parameters such as the type of the electric fluid, voltage, peak current, duty factor, pulse on time, pulse off time, and the polarity will be kept constant. There are 4 machining response that will be investigated, which are surface hardness, surface roughness, coating layer thickness, and lastly, the layer composition. In this study, steel will be used as the workpiece material, while copper will be used as the electrode material. The TiO2 will be used as a coating agent because it has good hardness, excellent corrosion resistance, and good wear resistance. Lastly, during this study, the different concentration of TiO2 powder will be applied. This is the literature review from the previous journal that related with this topic. The conclusion from this previous research or this finding, we can see that when the powder concentration is increased, it will result in increased the coating layer thickness and surface hardness value. However, the surface roughness value will be reduced when the powder concentration is increased. For the methodology, this is the flowchart for the experiment. The first step, we need to prepare the electrode and the workpiece. Copper electrode will be go through the grind and polishing process in order to make the flat surface at the end of the electrode. Then grinding and polishing machine with the 320 grit sandpaper and 300 RPM will be used in this process. My steel plate with the dimension of 40 x 40 x 10 mm will be used as the workpiece material. Next step is the preparation of the mixture. The EDM kerosene oil, surfactant spun actified, and TiO2 powder will be mixed together by using sonic ultrasonic homogenizer type P series in order to produce the dielectric fluid. There are 3 different dielectric fluid with the different concentration, which are 0 gram per liter, 10 gram per liter, and 30 gram per liter of the titanium dioxide powder will be produced. For the EDC parameter defined, the information that contained in this table is the machining parameter for this experiment. All the parameters will be kept constant except the powder concentration. The machining time for each EDC process is about 15 minutes. Next is the EDC process. EDC process will be run by using EDM desinking machine. This is the schematic diagram for the experiment, which is use reverse polarity. During pulse on time, spark will be generated by the heat and will melt the material at electrode and particle in the dielectric fluid. Melted material will be deposited at the workpiece surface. During pulse of time, minimum spark will generate. At this time, the deposited material will be solidified through rapid cooling process and produce a layer. This process will be repeated until the machining time finish. Next is the measurement and analysis. There are 4 machine response that will be investigated. The first one, the scanning electron microscopic or SEM will be used to measure the layer thickness. The second one is surface profile measuring element. This will be used to measure the surface roughness. The third one is the X-ray diffraction or XRD analysis. This will be used to measure the layer composition element. The fourth one is the viscous hardness test. This will be used to measure the surface hardness. Lastly, all the data that has been taken will be discussed during the result and discussion. Lastly is the expected result. For the expected result, when the powder concentration is increased, it will increase the material deposition rate. Indirectly, it also will increase the layer thickness and surface hardness. However, the surface roughness value in terms of RA value will be reduced when the powder concentration increase. That's all for me. Thank you.